In the experiment 1, we used the following materials: 1 speaker, 1 container, rubber bands, rice, salt, and water. First, we introduce the speaker into the container. Second, we cover the container with paper film. Then, we add rice in the cover of the container and we put sound into the speaker. Then, we add rice in the cover of the container and we put sound into the speaker. The explanation of this is the following. Waves are longitudinal waves. In other words, the particles of the medium of these waves vibrate in the same direction. The higher pressure in the wave is called compression because it pushes air molecules together. Meanwhile, the lower pressure is called a rarefaction because it pulls air molecules apart. With the rise, we are seeing the different waves produced by a song. The mix of compression and rarefaction is caused by the sound hitting the air and hitting the material upon it. The movement of rise also depended on the frequency, higher frequency showing a higher movement.
We remove the rice, also added salt in the cover of the container, and finally, again, we added sound. The result was that the salt started jumping. With higher vibrations, the salt jumped more. The explanation is that it happens the same that occurs with rice, but as the salt is a material of less mass and density, it can move with lower frequencies. Conclusion. We can conclude that objects can move with sound depending on the frequencies applied on them, and also depending on the mass of the objects. The salt was capable of moving more because it had less mass than the rice, so the waves affected more the salt. It was really interesting to see how the sound waves of the speaker worked. We saw how they push the air moving the paper film and the material we put on it. Now we realize that it was a longitudinal wave. The knots of the wave are marked by the red dots. In the knots, there is no sound, also reflected in the points where the salt and rice came back to the surface.
For the experiment 2, the materials we needed were 2 glass cups, water, 1 paper sheet, salt, and also coffee. For the procedure, we filled 1 glass cup with water and let the other glass cup without water. We put a paper sheet to cover one of the glass cups and we added coffee. Then we put together the glass cups and we made a sound with one of them. After that, the coffee started to move.
Ahí se está moviendo, ahí se mueve. Se mueve más el papel que el café.
Allá.
Está allá. Ahí está.
Ya se ve tantito donde se mueve.
No te preocupes.
As a result, the coffee successfully moved. But for the conclusion, I am going to tell you why. The reason the coffee moved was because when you made a sound with one of the glass cups, it created a vibration in the air. Those vibrations can cause the paper sheet covering one of the cups to move slightly, creating a small airflow between the two cups. Now, this airflow can disturb the surface of the coffee, causing it to move. Additionally, the vibrations from the sound can also transfer to the table the cups were on when we made the sound and the coffee moved, which can further disturb the coffee and make it move.
As an experiment 3, the procedure of this experiment, we use the sounds that the cups produce when they have little water inside, in addition to wetting our finger a little, with which we will make circles to the cup. We produce sounds with the movements. As a result, in this experiment, we use the proofs produced by the proofs to move some matches until they touch each other. In the experiment, we will show how the matches have sudden movement due to the vibrations of the other cup. Thank you very much.
Experiment 4. Materials we need: 1 cup and 3 rubber bands with different length. What we did was place a rubber band along the cup to make a sound. In conclusion, rubber bands make different sounds depending on how stretched they are, due to their structure and composition. When an elastic band is stretched, it becomes longer and tighter, causing it to vibrate and produce a sound. As it is stretched further, the tension increases and the sound becomes higher pitched. On the other hand, when an elastic band is not stretched, its tension is lower and it produces a deeper sound.
So for the experiment 5, the materials were 1 glass cup and water.
So the procedure was: first, we fill with water almost to the top of the glass. Second, we produce sound by rubbing with our wet finger the edge of the glass. Then we remove a little amount of water and we produced sound again. We did this several times with different water levels to produce different sounds. As a result, the pitch produced by the cup was getting higher when it had less water, but when it had more water, the pitch was lower. Another thing that we observed in the video is that there was a moment where the pitch could not get any higher, and this was because it reached the limit of vibration that the glass cup could make or produce. So now to explain the phenomena of the pitch getting higher or lower depending on the level of water is because water makes the glass cup vibrate slower, creating a lower frequency which results in a lower pitch. And when there is less water and more air, the glass cup vibrates quickly, creating a higher frequency, resulting in a higher pitch. In conclusion, the pitch will get higher if the water is lower, but if our glass cup is filled up, the pitch will be lower instead of higher, creating different vibrations and sounds depending on the water level.